All right. Sometimes we see, say, a ship in the distance upside down, like it's floating upside down in the sky. So what I've done here is I've created a little blue mountain. We're seeing a side reflection, but this one right here is the actual, it's just a tape triangle, but that's our mountain. It's on the far end of the fish tank. But you can see just above it, we are seeing a reflection of it, as well as a reflection of the the black the black road down here too. But so this upward mountain is actually a reflection, an inverted reflection off of the density gradient due to total internal reflection, because down here is brine and up here is freshwater. And so when we get below there, we're seeing the lower mountain directly and then seeing it again inverted above upside down. So you might wonder, what path is the light taking for this to happen? And now I will show you. I will show you why the top of the mountain in the reflection appears down below the bottom of the mountain in the reflection. What I've done is I have set up 4 little lasers here. Let me take out my stop block. And these 2 lasers represent the lower line of sight, and these 2 lasers represent the reflected line of sight. So let me shut out the overhead. Okay, so and turn out my headlamp. Okay, look at that. Let me get back a little. So now you can see there's 2 sets of rays. See these lower 2 here? They go out. They do not cross over. One goes to the bottom of the mountain and one goes to the top. That's the path of the light, showing the right side up image of the mountain. Now the upper 2 here, see these upper 2, they go up and they bounce off of the refractive gradient layer. That one bounces there and starts back down, but this one bounces off here and starts back down. So you can see those 2 lights, those 2 rays cross over. Let me block off just the reflected lasers. I'm going to put a block in front of those 2. Now we have just the 2 that are the uninverted image. So you can see the two rays of light don't cross each other. So in this case, for this path of light, the top of the mountain will appear on top because it goes all the way back and comes in on top at the observer, and the one on the bottom will appear again on the bottom and come all the way along and stay in the bottom. So it will appear right side up. Now let me switch to the other 2 lasers. Now you can see that the ray that starts out at a higher angle hits the reflection, turns down and starts going down and actually ends up lower. So the higher ray crosses over and ends up lower. The lower ray crosses over and ends up higher. So this is the basic rule for reflection. When the rays of light cross each other once, then the object will appear upside down. If they don't cross, then they will appear right side up. Now, if conditions were really strange and they crossed twice, then it would still be right side up, because the first crossing would turn it upside down, and the second crossing would turn it right side up again. And so on and so forth. As long as it's an even number of crossings, it'll be right side up. If it's an odd number of crossings, then it will be upside down. Let's take a closer look at this here. And it wouldn't matter whether it's light coming from the mountain going to the observer or the other way. The light would take the same path either way. So here's the observer and the 2 rays of light coming out, moving along. One hits the top and starts curving back down. Now they cross, Right there they cross, as close as I can, and then they diverge again. Then the other one hits the top and bounces back down, and they still reach to the top and the bottom of the mountain, but it makes it inverted because the light coming from the bottom of the mountain ends up crossing over and coming in from above. So that makes the bottom of the mountain appear higher than the ray from the top, because this one is the ray from the top, and I'll trace that out for you. See, here's the ray from the top of the mountain. It goes along, but then it crosses over, so the ray from the top of the mountain comes in from below, which makes the top look below the bottom. So we can actually kind of possibly see that if we get, well, there's an awful lot of reflections going on there. That's pretty, but I'm not sure you can see what I'm talking about. Well, we tried. Now going back to the non-mirrored, now you can see that the upper ray stays upper the whole time, all the way across, and goes to the top of the mountain. So in that case, it would look right side up. Now, what happens when we're seeing both a right side up and an upside down, like I opened the video with? Let me turn back on all 4 lasers. You can see now we have 4 paths of light. These 2 higher ones cross over, and they form, so like these 2 higher ones that are crossing over, those are forming the upside down image. That's how you see the upside down image. These 2 down here, which are not crossing over, is how you see the right side up image. But you can see each, basically the top of the mountain is sending off light in all directions. One path goes up here and gets inverted compared to the one from the bottom, and then the other pair, they don't get inverted. So hopefully that makes sense on how we can see something out on the horizon twice and once upside down. There are more complex things that can take place. There could be a gradual gradient in here as well that causes these lower ones to curve a little but not cross, to cause it to appear lifting. Or there could be a hot road mirage effect on this surface here, which actually would bend light back up as well, creating yet a third route, causing another reflection. So we could actually see the mountain once right side up, and then once upside down above it, due to the top side crossing over. And then if there was a top heavy density gradient like a road mirage down on the surface, we could see a reflection, another reflection of the mountain below where it is, also upside down, because it would be a reflection, and that's why road mirages appear upside down as well. So there you have it. I hope that helps explain mirages for you. Oh, now you can see the 2 mountains, and you can see the rays of light going to them, sorta.